we'll just start with our tree of life diagram. You know, the tree of life has these 6 kingdoms across the top. And then somewhere about 3.8 billion years ago, the first cell showed up. We don't know exactly where it came from, but it's not important to our story. This cell is having a good old time swimming around the ocean because that's where the first cells were, we think. And then after a few hundreds of millions of years, some other cool cells evolved from that first cell. So I'm going to introduce some of my other friends here. So they're just having like a huge party, right? And after, I don't know, a couple 100 million years, one of the cells branched off and became known today as our normal bacteria, all right? These red ones were pretty cool. You know what was neat about the red ones? They were really good at converting sugar into ATP. They're a feature player of our story here. At some point, these guys branched off from the tree of life and became the archaea. Well, about that time, Bruno shows up. Bruno was a big bad dude, and you know, he was kind of greedy. And Bruno decided that one day he was pretty hungry, and he was a little bigger than the others, so he just swallowed this guy. And this guy ended up right inside him. And Bruno was very happy about that. And that happened somewhere around this period on our tree of life. And Bruno became the first eukaryote. And this thing that he swallowed was really good at converting sugar into ATP. And this thing became the mitochondria. And what was cool about these mitochondria is that they didn't die when they got in there. They actually could reproduce inside Bruno. And today, all animals, fungi, plants, and protists have mitochondria in our cells. And so for every one of your 100 trillion cells, you have bacteria swimming around in there that are kind of free agents. Okay, now at some point in the story, Bruno had a cousin named Smedley. Now Smedley already had the mitochondria because they were cousins and they share features. Well, Smedley was a little bit greedy too, and this unsuspecting green guy who was really good at converting the energy of sunlight into sugar was swallowed up by Smedley. And Smedley was like very happy about that, especially because these green guys started reproducing inside him. Now this happened on the tree of life for sure on the way to becoming plants. And plants have both mitochondria and the chloroplast. These are known as collectively endosymbionts. They used to be free-swimming bacteria living out in the ocean, but now they're inside plant and animal cells. The plant cells, of course, have the chloroplast, and that's what makes them green, and they can capture energy from the sun and make sugar. But they also have mitochondria, because they can take that same sugar that the chloroplast made and convert it into ATP. Now, our story is a little bit questionable because there are some protists that have chloroplast too. And there's a little bit of a debate on how the chloroplast got in there. It's possible, and this is one of the hypotheses, that this swallowing of the chloroplast happened here on our tree of life. And so that would explain why protists and plants would both have the chloroplast. But then that would not explain the animals. But it's possible that on the way to becoming animals, some, and it's unclear, animals and fungi, the chloroplast died out. And these animals and fungus are just left with the mitochondria. There's a debate about that. But the take-home message is that the mitochondria and the chloroplast used to be free-swimming bacteria.